visit, and disease prediction and monitoring. It is within this context that our subject fits, more precisely in the Parkinson's disease. According to Global Burden of Disease, Parkinson's disease is considered as the second most common neurodegenerative disorder after Alzheimer's disease. About 6.2 million people affected worldwide in 2015, with 117,500 deaths and nearly 1% of the world's population over 60 is affected. It is characterized by the loss of dopamine-producing brain cells. As shown in this figure, the first neuron corresponds to a healthy subject and presents a normal and sufficient dopamine secretion, which reflects normal movements in the subject. However, the second neuron corresponds to a Parkinson's disease subject. There is a poor secretion of dopamine that leads systematically to movement disorders. In this case, people start having hand and foot tremors, difficulty in walking, writing, speaking, and many other simple tasks. These symptoms continue to develop over time. This progression of Parkinson's disease includes 5 different stages. From one stage to another, the disease evolves progressively as the degree of tremor increases. The patient may lose balance and becomes confined to a wheelchair in the later stages. In order to occur an accurate diagnosis, physicians analyze and process medical images called positron emission tomography, also called PET scans, that proved its success in detecting the dopaminergic dysfunction in Parkinson's disease. As this disease progresses over time, a volume decrease of this region called basal ganglia will be visualized in PET images. Consequently, focusing on the size of this region, physicians can confirm or decline the Parkinson's disease evolution in a specific patient. So how to treat efficiently basal ganglia regions and which technique to use to detect basal ganglia regions. In order to help and assist physicians in detecting precisely the basal ganglia region, we propose to gain from the performance of artificial intelligence techniques and focus on image segmentation. Among these techniques, global thresholding proved promising results using many types of image for the diagnosis of numerous diseases. In contrast, to the best of our knowledge, there is no previous work in literature that focuses on basal ganglia segmentation. Hence, our main aim is to apply this technique to test its accuracy in segmenting this region from PET images. First, we get access to the Parkinson's Progression Markers Initiative database, which covers study data that include more than 2,800 features stored in CSV files, such as motor assessments, subject characteristics, medical history, and genetic data, and also image collections, including MRI, fMRI, CT, DTI, and PET images. In our case, we focused on using PET images to segment the basal ganglia region, and this by using global thresholding technique. It converts a grayscale image into a binary image through assigning all pixels greater than a specific threshold value to be foreground and all other pixels as background. The determination of an optimal threshold value remains a challenging task in thresholding technique. Several different methods exist in literature, such as the use of histogram. However, this method doesn't deliver an efficient threshold value for all types of images and may be computationally expensive. For this reason, we propose to select multiple seed points for the basal ganglia region. The second step consists on finding the intensity value of the selected values. We have noticed that all the intensity values vary between 140 and 160. Therefore, in order to get high accuracy in the segmentation process, the threshold value must belong to this range. Thus, we have chosen to test 3 different threshold values between this range, which are 140, 150, and 160. After that, for each input, we read the image as grayscale, thresholding it using threshold values selected, and save the resulted image in the output files. On the whole, our proposal is composed of 4 fundamental components. First, we focused on PPMI database to extract PET images. As we aim to study the progression of Parkinson's disease patients, we were based on only patients who have more than one PET image. Hence, a total of 110 chronological PET images were selected. The second step consists in manually segmenting PET images using ImageG, which is an open software platform that had a large impact on the life sciences. In the third step, we focused on images selected from PPMI database and applied global thresholding algorithm using the three different threshold values identified. In the final step, we performed the evaluation step based on the ground truth constructed to ensure the precision of global thresholding. For comparison performance evaluation, as there is no previous work in literature that applies segmentation of basal ganglia from the same PET images dataset, we choose to perform another segmentation technique called Otsu's technique. Unlike global thresholding that requires a selection of threshold value, Otsu's technique can automatically identify the optimal threshold value. So we can further compare the evaluation performance of the two techniques applied. For evaluation measures, we evaluated the segmentation results using the most effective metrics for segmentation tests, dissimilarity coefficient and mean intersection over union. They measured the similarity between the ground truth and the resultant segmentation image. The DSC is defined as the area of overlap divided by the total number of pixels in both images times 2, while mean IU is defined as the intersection between the two regions divided by their union. The value of these two metrics may vary between 0 and 1. Larger values confirm a better spatial agreement between ground truth and automatically segmented regions. Here we take an example of one image as input to our proposed approach using the three thresholds. We can notice that the selected regions are very comparable with its corresponding ground truth image. When evaluating the accuracy for all images in dataset, we noticed that global thresholding segmentation technique using PET images was highly accurate for all threshold values tested. Furthermore, the high performance is detected using 150 as threshold. When applying Otsu's technique on the same dataset, it provided inaccurate performance since the average of DSC and mean IU were very low. This can be explained by the fact that the automatic selection of threshold value by Otsu's technique does not provide the intensity value of basal ganglia region, which is not the case for our proposal that searches first of all of the intensity value of this region and then applies global thresholding with an exact threshold value. To conclude, we validate that our proposal that focuses on global thresholding proved promising results for basal ganglia segmentation and outperforms Otsu's technique. The output images help physicians in the detection of Parkinson's disease progression. Despite the notable performance achieved, this study has several limits. First, the construction of ground truth images aren't conducted by experts. Second, the selection of threshold values using multiple seed points may not be an effective method. In addition, global thresholding cannot guarantee the segmented regions are contiguous. Therefore, in the near future, we aim to overcome these drawbacks using deep learning model in order to segment the basal ganglia regions in PET images. Besides, from the segmented images, we aim also to calculate automatically the basal ganglia size and predict the progression of Parkinson's disease. Thank you for your attention.
Yes, Dr. Paliwal. Shall we move to the next paper?
I have one comment. If you can approach to the author, she has taken intervals like 140, 150, 160. I can identify there are discrete intervals are possible between these two ranges. So author is advised to get the optimal threshold value because she has discussed things. Optimal threshold can be identified, but it is not in the range somewhere 140 to 160. So somewhere the author can be notified about the same. So there's a small suggestion from my side.
Right. Thank you.
Okay.
So next paper is 244. Is author of 244 present here? 244. authors of 244. Yes, Riddhi Thakur, let me make you presenter. Okay. Yes, Miss Thakur.
Hello,
Yes.
am I audible, sir?
Yes, you are audible. You can start your presentation and share your screen.
Yes, sir.
Yes, Mr. Kumar, you have any?
Yes, yes, sir.
Yeah, hello.
And sir.
Yeah, can you please for paper 244 ID, can you please unmute Dr. Gopi Chand? Like he will be presenting.
Okay. Picture.
Okay, okay. Dr. Gopi Chand.
Okay.
Sir, I have shared my screen. Is it visible?
Yes, it is visible. Visible.
Okay, so sir, shall I start?
Yes.
Okay, so good afternoon, everyone. I am Riddhi Thakkar, full-time PhD scholar from CSE Department, Institute of Technology, Nirma University.
For
My
internet, your
yes,
paper
sir.
is 274.
Yes, sir. My ID is 274.
Okay, no problem. I was asking for 244.
Yeah,
No.
244.
I'm there, 244. I'm
Okay.
there, but you have unmuted, no? You unmuted everything. I couldn't able to raise my hand. I couldn't able to speak also. You
Okay.
unmuted every channel. You have to enable all the channel. Let other present and all. We don't have any scope for raising unmute and talk and all.
Okay. So you may present your paper after this paper.
Right.
Is it
Right.
okay?
Yeah, fine.
Okay. Ms. Thakkar,
Okay,
you
so
may.
okay, sir. Okay, I'll start from the beginning. So, good afternoon, everyone. I am Riddhi Thakkar. I'm full-time PhD scholar, Institute of Technology, Nirma University. My guide and co-author, Dr. Madhuri Bhausar. She is HOD and professor in CSE Department, Institute of Technology, Nirma University. Today, I am going to present my paper, a novel approach for adaptive resource prediction in cloud. So this is the outline of my today's presentation. First, I will be giving the overview of the paper, then the motivation behind this paper and the proposed approach. And then I will be discussing the experimental result and the analysis of it. Then I will conclude my talk and will also discuss the future work. So with the advancement in the technology and the access of internet have increased the number of cloud users. The cloud users can get the services on that based on their demand, and they are charged based on their usage. So so the cloud services have significantly improved the service provisioning, and have also significantly reduced the amount of cost for the same. From the perspective of cloud service providers, it is highly required to optimally utilize the resources and avail the services, cloud services, to its user based on that requirement. So the cloud service provider must be optimally utilizing its resources. The resources can be availed to user in two way: in reactive approach, in proactive approach. In reactive approach, the resources are allocated to the users once they have requested for it, and in proactive approach, the resources are allocated to the user before they have requested. Here in proactive approach, the certain amount of resources are allocated to the user before the requirement. If the resources allocated to the user are are more than their service requested, then the resource wastage resource wastage had happened. And if the resources are lesser than the requirement, then there is a shortage of resources. So in order to avoid this situation, the cloud service provider should accurately predict their resources. So here that is the main motivation behind this behind this paper is to accurately predict the resources and scale the resources based on the cloud service users demand. So while designing the cloud resource prediction model, few challenges that must be attended by the cloud service provider. So the first one is versatile. The model should be able to predict the resources for any user and any application, and it must consider the cloud resource heterogeneity. Then the prediction model should be less complex, as well as it must accurately predict the resources. The cost for the model should be less with the perspective of time as well as the money. And the model should reduce the risk of over provisioning and under provisioning of resources. And the prediction pattern length for the resource prediction should be accurate. If the prediction length is not accurate, then the resources should not be accurately allocated to the user. So such challenges should be considered by the cloud service provider while designing the cloud resource prediction model. So we have considered this prediction challenges and proposed one model, that is NAAR-PREC, that is novel adaptive novel approach for adaptive resource prediction in cloud. Here we can see that the historical data is taken and first it is pre-processed. Once the data is pre-processed, the cloud service provider is required to define the R flag, that stands for requirement flag. Here we have considered the time constraint as well as the accuracy. If the service provider wants the quickly resource prediction result, then it will be going with the LSTM model. Then the R flag should be set to 1. Here we have taken LSTM model because it remembers the previous history, and based on that it predict the future resources accurately. Now if the CSP wants to hire CSP is not bothering about the time, and he or she wants the accurate result, then they are going with the hybrid model. That is for that that the R flag should be set to 0. And here the ARIMA plus LSTM model is used. Now ARIMA model is used for the hybrid approach, is that if the data is linear, then the ARIMA is the best choice for the resource prediction. And if there is a non-linearity in the data, then the LSTM model is chosen. So here we have considered the complexity, we have considered the linearity in data set, and based on that we are predicting the resource utilization. So in order to evaluate this model, we have taken the BitBrains dataset, and the BitBrains dataset is consisting of the data of 1250 VMs, and the results the data is collected for 1 month, and the parameters which are collected are timestamp, total CPU cores, its utilization in usage, its utilization in percentage as well as in megahertz. It is also covering the memory utilization, disk read write throughput, and network receive and transmission throughput. Here we have considered CPU utilization and memory utilization for prediction. So in order to check the accuracy of model, we have checked the RMSE and MA, that is root mean squared error and mean absolute error for the proposed model. So in this graph, we can see that this graph is showing the CPU utilization for the model, CPU utilization, and the blue line is for actual value, and red line shows the predicted value. Here we can see that the model is able to accurately predict the CPU utilization for the given time series. And the next one is memory usage. Here also we can see that the blue line is actual memory usage, and the red line is red line is predicted memory usage value. Here we can see that the trend for the memory usage is followed. From this we can from this experimental results we can say that the model is able to follow the trend in follow the trend in the given data, given input, and trying to accurately predict the result. So here we have targeted the seasonality and irregularity in task patterns, and we are able to attain 90 percentage of accuracy. So in future we are trying to improve our model, and we will also be evaluating this model for the different parameters. Here we have only evaluated CPU utilization and memory utilization, but in future work we will be evaluating the network network and disk read write throughput, and we are also working on the we are also working to evaluate this model on the real world cloud data set. So this is the today's uh, this is my work for this paper, and we are still working on this model, and we are enhancing the results. So yeah, thank you. Any queries?
Uh, yes, Riddhi ma'am, I have a one query. Like
Yes, sir.
you are taking historical data regarding the utilization of a particular user, right?
Yes,
So
yes, sir.
how your model will behave if the requirement will become continuously changing, right? Every time you get a new request regarding every resource.
Yes, sir.
So how your model will predict that cases? Because there may be such cases where the requirement will be keep on fluctuating every time. They are not similar.
Yes, sir. Your question is very nice. And sir, actually, for the sake of evaluation of this model, we have just taken the existing data set. But yes, I am working on the same where I am taking the real time platform, and where the data is where the requirement is continuously changing, and we are evaluating this model on the same. And for that, I have chosen the Apache Storm platform, which is a real-time distributed stream processing platform. So with the help of this platform, we are continuously having the requirement for the resources, and based on that resource uh, based on the resource requirement, the prediction is performed, and resources are dynamically allocated for the service for the requests.
Okay. So I strongly suggest you to please incorporate this because this is the need of any type of cloud environment, dynamic provisioning of the resources.
Right.
Yes, sir. This is my thesis topic, and I have also completed the work around 90%, and will be submitting the
Okay.
paper for the same.
Sure. Okay. Thank you.
Thank you so
Any
much, sir.
question? Any question from the audience? No question. So Dr. Paliwal, we'll move to the next paper.
Sure, sir.
Paper
Yeah.
ID is 244. Author
Yeah.
has already started his presentation.
Yeah.
Doctor,
Can you able to see my presentation?
yes, we can see.
Yes, it is.
Yeah. Thank you very much. So yeah, I belongs to, I mean, I work for Lab 45 Wipro Limited. Okay, this is a paper co-authored by Abhishek, Rasekhar, and all. They have already joined the call for this particular paper. This is more on the method for workflow segmentation, where we are looking one of the solutions as part of R&D in our Wipro, and predicting the workflows in the video data, and use that content for the AR applications. So the sketch of the talk goes like I'll go with the literacy survey and what are the current solutions which are available in the market, and also the high-level architecture for the particular problem statement what we are attacking on as part of R&D, and the workflow creation with respect to video content data, and also the summarization modules, text summarization, which we goes how you can extract the summary, extractive summary or abstractive summary from the speech of the video content data, and also we can use the sequential model as part of AR content creation, and the application, couple of applications, and the conclusions, and path ahead for this particular problem statement. So as you see that like many folks which are already talked about the use of convolution neural networks and multiple applications, and this is also convolution neural network and a part of video segmentation. Also we have the supervisor method and unsupervised method. So as part of supervisor method, people are using kind of temporal convolution neural networks where we can get different actions from the video segment data, and it is applying multiple use cases like supermarket use cases and other making salad, and there is one paper which I cited in the references and so other applications like machine learning. Typically, if you see the unsupervised method and all, we can use the machine learning approaches to cluster the features of the images, and other like a feature descriptors, and also the feature matching and to match the frames features, and I'll see where we need a segmentation of couple of algorithms which are already available, and also summarizing techniques basically we'll use for get the summary of the video content data and see what is happening in that particular workflow. Basically, all these workflows will be using on the AR content creation. I'll be talking about in the next few slides. So the problem statement is like as I spoke, right? How will you segment the data? The data, video content data, what we used is here is for maintenance repair data, and this can be extended to any kind of video content data. Now, how you segment them? Segment in the video content data with multiple features or multiple frames which are there, and which is a differential from one frame to another, and all. How will you segment? So what we did is we used the unsupervised approach where we have taken the video content data and extracted the frames and use the pre-trained models like CNN approaches or kind of feature descriptors and to extract the features, and also see the features are compared from the subsequent frames where we have get an intervals where the segment is already different from one frame to another frame. So the time at which the frame features are different, that is a different action in the particular video segment data, and the threshold which we are managing, which can help you to tightly differentiate the different dissimilarity actions, which can help us to create the AR content for our repair and maintenance actions. So from the video speech data and that from the voice enabled data, which is there in the video, and which can also help us to get the summary of what is happening in the each particular segment and all. So the LSTM models which we use it for is for creating the multiple actions, which is not sequence. Let's say in the workflow, if you started with some action which is not sequentially, but the LSTM model can help you to where you are in the currently in the video and all. So that will help you also creating the predicting the actions from the video content data. So what we use is we use the video data as an input which has a speech enabled, and we have used WARB algorithm and case multiple algorithms to extract the features, because we want to see the particular use case for the customers which we are having is more related to the any kind of repair and maintenance. We don't have any supervised methods. We don't know what are the different actions and what are the different procedures for each action, and we don't have any supervised information. So we have to attack with respect to the unsupervised method alone. So in that case, what we have to see, we have to use what is the unsupervised methods which are available in the literature, which we'll be using for segmenting those videos, and also we will leverage those methods to get the workflows for particular video data. So we use the case and WARB algorithm to extract those features, and also we use some kind of CNN approach also in this method. So particular videos and all the unsupervised method doesn't help us. So what we do is we use the we skip the last layer. We use the last layer where we have the extracted 4096 features from the CNN approach, and those features can be used to differentiate from frame to frame and so once we have sequentially, once we have matched, then we'll use a cosine similarity how the features are different from one frame to another. So we got the intervals predicted from one segment to one segment, which is different from that one action to another action. From those segments and all, what we try to do is we try to get what the for each segment what the information talks about, whether it will be removing the screws or whether it will be battery replacement. All these are a couple of based on the video data and what it talks about for each segment. So what we used is we got all the multiple sentences from the segment, and we use a lot of pre-processing approaches and along with the beta algorithm, which can help us to get the contextually derive one segment to another segment, how different it is. So the extract level summarization, which we got it from the beta algorithm, which will help us to define for each segment what it does. So it is the user is trying to remove the battery in one segment, another segment he is try to replace the battery, another segment is something like he is try to fix the whatever the issues are there. So those are the summary context level which we are getting using the summarization approaches and the workflows and so we use the beta algorithm and couple of algorithms. We try to get the context for it, and we use the what to vec and glow vectors to create the word embeddings of those keywords. So we obtain the highly relevant keywords using what are the sentences, and those keywords will help to get the context level summary, which is the extract level summary. So if we don't want to extract level summary altogether, you can go to abstract level summary also, which can help you to get the context overall building a tree kind of structure, and I'll get the context for the sentences and derive the sentences which are helpful for each of the segment under. So the once we have all these content ready, so what we taken is we have taken this into the AR applications. So the AR applications, so we have the couple of products which are there in the Wipro, where we are using for our customers and all. The research part which is like training those workflows. So training those workflows means so what we do, we will augment the content. Once we are repairing and all, we'll augment the content and workflows from each of the segment what is happening. So those segment augmentation is really happening with the training models with each of the workflow using object detection approaches, using like a CNN approach or any kind of approaches for faster CNN method, RSS, whatever RNN method and all. So which will help us to predict the objects, what are the objects which is present in that workflow, and what is the action associated with that. Let's say he's removing the screws which is not there in the current stage, and it will help you the action. This is the action which is remove the screw, and also the sentences what we derived under will play those sentences. So this is more like automatically creating the content and workflows from the video segment data, and all these information will be pushed into the HMD devices like we have HoloLens and like kind of Magic Leap and RealWare devices. And what we do, we put the content into the HMD devices where user will be viewing all the content while real-time streaming and all. So once you user view the real-time streaming data, what will happen? This is the object detected using the this is what the segmentation will happen offline. Once we have all the content pushed into the AR devices, so then we will real-time the streaming. So the object detection, once we have the object detected and detected and what is the action associated with that particular object, and then the workflow will be played as augmented on top of that and the spatial content, spatial world. So the action is like remove the battery, action is like remove the choke, and those are the actions which will be played. So the based on that, the user will be performing all the repair and maintenance and so without manually asking and calling, without having a field actually service engineer who is expert in that, we don't need that. So the real time and all, we will use that content and which is played on the our HMD devices, which will help us to do yourself, and otherwise to which has a small knowledge in that domain and all without interference of other people. Okay. So
Dr. Agnihotram, sorry
yeah.
for interrupting. Please complete your presentation in 3
Right,
minutes.
right. Yeah, sorry. So the application which I'm able to complete, the application is in the laptop repair, and we have a couple of applications, the CT scan, MRI scan, we have used this solution, and that will help you to repair and maintenance for particular healthcare devices, and also it can be extended to any kind of use cases. So the conclusions of what I made, like we use the work, how the video, from the video, how you segmented the data, how you use the workflows, and for the AR content creation, and this can be put into the mobile devices or HMD devices for action prediction and so this is how the paper paper we described in the presentation. And also path ahead is like what we do. So we use the we are planning to use the fusion based approach where vision and voice both can be measured together and see how the workflow can be predicted with more accurate. So they currently it may be happen like the intervals may shift here and there, but if you fuse with the vision and voice in the while creating the workflows and that may help us to create the accurate workflows and also this can be extended to other use cases, e-commerce and healthcare retail applications. So these are the references. Okay. This is the how the solution goes, and also its paper is co-authored, as I said, like Abhishek and Surbit Raja and Reddy and Raja and Pandurang Naik. So thank you very much for the co-authors as well. A couple of people are present, and if you have any questions, I can take those questions.
Yeah, thank you, Gopichand sir. I have one query, like it's a very generalized query right now. Let's suppose we have a two frames. One is representing battery fixing and another one is representing battery removing, right?
Right,
So
right.
is it considered as a two different scenario? Because
Yeah,
pixel-wise
yeah.
representations are almost same. So during workflow representation, is it a single frame or two different frames?
So the sequence when you are capturing, right? The sequence, the similar video we played, okay,
Right.
the removal of the battery is one segment, and also fixing of the battery is another segment. So whatever the scene approach and the feature descriptor method which we used here, it can able to identify these are two different segments. Okay.
Okay.
So
They
so
can
first,
accurately detect it.
yeah, it detected the intervals where it got stopped, right? It got detected
Okay.
for this particular
And you
approach.
have said that the threshold is very dynamic. Like somewhere you need to increase the threshold. Somewhere the two different
Exactly, exactly.
sequences have a
Right,
less
right,
threshold. So
right,
how
right.
you are managing that things?
So the what we do is this is like totally the offline model, right? Somewhere like when you are creating a segments, it may happen like few frames will go here and there because you may not be having the enough features in the two segments, right? So what we do, the threshold of question similarity of feature matching and all. So sometimes a few of the videos it may happen like we could able to get that segments with 0.75, and sometimes it may happen like 0.98 and 0.90 and so we will see how the segments have happened because these are totally automated. We don't have to manually see under just one click and we could able to create all the folders, all the files, everything. We just go through one by one frame and since it is an a priori, right? Before porting to the HMD, it is an a priori like where we will have the freedom to look into it. So if you feel like some frames are not happening to be correct and all, what we do, will increase the threshold. It may happen like it may reduce the threshold and that also it may happen. And also there is a threshold for extracting the futures. Okay, so it may
Okay.
have, we may see that we given the threshold like extract only 50% of the futures, 60% of we will tune there also. Okay,
Okay.
so both the things will tune here and see where the actual intervals has predicted because it's unsupervised method. No.
Okay. Nice presentation, sir. Thank you.
Thank you, Mr. Thank you.
Question from the
Yeah.
audience, participants, any question? So Dr. Paliwal, we'll move to the next paper with paper
Yeah,
ID
sure, sir.
87. Author is Mohammad Lagari.
Yes, good afternoon.
Good afternoon. You are the presenter, so you
Yes,
can
I'm the presenter. So, right.
you can start the presentation and you can share
So
your
how do I
screen.
share the screen? The only thing is, how do I share the screen here now?
You don't know? Are you using Windows?
Right, here's Microsoft PowerPoint.
Then, but you need to go to the Microsoft team and there is like one button, share button
Just a minute, let me.
on the top left side.
Yeah, share.
Just click
And
on
I
it.
share the contents from camera or
Share the
no,
window.
share from the screen I want.
Just
Windows,
click
right?
that window and select this presentation PPT.
Yeah, can you see the presentation?
Yes. Switch to the presentation mode.
Yes, I'll do that. Okay, right, I think it's clear now.
Thing is fine.
Okay, yeah, so I'll start. Good afternoon. I'm Mohammad Shakir Lagari, and the co-author of this paper is Dr. Ahmed Hassan. I'm from Electrical and Communication Engineering Department, and Dr. Ahmed is from Architectural Engineering Department. Okay, my research interests are software engineering and applied artificial intelligence, whereas and also renewable energies, where Dr. Ahmed is more in renewable energies. Okay, so title of my topic today is a software system for smart course planning. I'll directly start. I have a small introduction. Our university says I have to go through these small things once we do the presentations. So here it is, the University of the Future, established in 1976. We have about 14,000 students from 79 countries. We have 9 colleges. We have 9 research centers and institutes. We have 1 science innovation park. We are number 1 ranked in the UAE. from QNS. So the rankings are from QNS and Time Higher Education THE. Okay, and we are ranked in QS global ranking 296. In global ranking of 251 for the Time Higher Educations. Number 6, we are in the Arab world, and we are the top, we come under the top 50 universities which were established in the last 50 years, and this in the whole world. Okay, and this is the campus we are having. This is the new campus. We moved here about 6-7 years ago, and all the departments are here. So definitely my office is somewhere here on this side. Okay. Right, so contents of my talk are introduction and the package, the test cases, and the conclusion. Right. Students' course planning and advising is an important as well as a trivial process that may encounter unnecessary graduation delays. Lack of a proper planning and advising system. Although we have our advising system, works kind of thing. But it's not as sophisticated as it should be, because with the number of students, multiple problems can come up. Awareness and experience of advisors, definitely with large number of students, every faculty is given a set of advisees. So typically each faculty member can have something like 30 to 50 students. And then definitely new faculty members don't have that kind of experience to advise the students. Another thing is the students' ability to seek good advice. That's another problem. Students come, we make them understand things, but they cannot comprehend what is the importance in that advising. So the ability also to seek good advice is also there. And definitely inappropriate advising times and schedules. We give times for advising, and typically students have some kind of chores at the time, and they never come at that specific times. And then afterwards they say we missed those times. Okay, students may suffer problems such as course selection with time conflicts. Definitely they can select courses unless they go for registration. So we are in the phase of planning. They will not see the thing. So this is the whole idea of this project was. Okay, missing out on suitable courses. Then there's another thing. Some courses are offered on specific semesters. Some are offered in fall. Some are offered in spring. And they plan for take courses which are offered in different semesters. So this is another thing. Choosing electives by passing track restrictions. Although we don't have tracks, but we have two disciplines in the department. One is communication engineering, other is the electrical engineering. And what we have here is students are allowed to take courses from both disciplines, but they will not be counted in their degree calculations. So if they are allowed to take 4 electives and they choose an elective from communication track, the electrical engineering student choose a course on communication track, the system would allow, but in the end, the student will have to take 1 more course. Okay, select too many or too less courses. Again, selecting too less courses will delay the degree, and too many courses will affect their GPAs if they don't do well in all the courses. And again, selecting unnecessary incorrect courses. So again, chances of general education courses, if they select not correctly, then they don't benefit of this thing. And for whole of this smart course planning system is devised. Okay, so we have 1,900 students. Electrical engineering and communication department has about 250. Now we have increased to up something like 300. Okay, we have 147 credits for a BSc degree in this. Average course load is from 15 to 18 credit hours. So 15 credit hours is typically 5 courses. And from 4 to 6 courses, depending on if the student's on probation, then he's not allowed to take more than 4 courses. And often 7 with labs, so it can go up to 7 courses per semester. And they take up from 8 to 10 semesters to complete. So how these 147 are distributed, course load, 21 credits for the general education, 41 credits for the engineering requirement unit. These are common courses for the all engineering. And then the department 52 credits, then electives is 4 courses, which is 12 credits. And then we have a whole semester of industrial training. So a student go before or in between the last graduation project 6 credits. They go for, typically they go before they come for the last 6 credits, which is in the last 2 semesters. So in before the last 2 semesters, they go for industrial training for a whole semester, and 15 credits. Okay, look at the hierarchy chart. So I've shown this thing. The chart is really very important. Students are made to understand this chart very clearly. All the pink colored courses are the general education and university courses. The green ones are the engineering requirements. The blue ones are the departments, and the things shown underneath are the electives. Important thing about this chart is the hierarchy of courses and the number of courses opened, as well as the hierarchy levels. So for example, say Maths 1120, for example, if you look like this thing, or say my suggestion is Physics 105, how many open courses it will open in the hierarchy chart here. So that's the idea of the charts. Right here. So the building the general knowledge area of this investigation was, for with each course, all courses, I'll show you the next slides, two characteristics fields are associated with this thing. The first is the number of hierarchical levels, and then number two is the total number of courses to open for that from that specific course. So if you elect 305, here select 305, although labs are there, but labs we say, although it's a separate course, but we have included the labs in the course as well. So how many hierarchical levels it has? It has 2 hierarchical levels, which is like 1 and 2. Let's see if I can have. I'm sorry. Control options. Where's the point? Yeah. Okay, so we have 2 hierarchical levels there, maximum. I could have another hierarchical level there, then it would have been 3. And how many total courses does it open? So it's 1, 2, 3, 4, and 5. Labs are part of the course, so we do not include the lab in the count. So elective 5 comes with 2 and 5. And definitely a course with 1, 2, or 0, 1, or something like this thing has a lower priority to be selected. So students, when they go and look at the schedule, they find all these characteristics levels there in their presentation. So then they can choose the ones with higher numbers. Okay.
Dr. Lagari, please try
Yes.
to conclude your paper in 3 minutes.
Yeah, I'll try to finish. Yeah, just a minute. Yeah. Right. Okay, so this is the set of these things. So first one is the number of credit hours. Number 2 is the hierarchy levels, and number 3 is the thing. So like 305, if you look, it has a 2, 3 to 5, which is the 3 is the 3 credit hours of the course. And this is typically the class schedule would come out, and students will pick up this schedule for this project. They will pick up this class schedule, and they would deduce, that system will deduce something like this thing. And this is for all of the courses offered in this specific semester. So this is for spring 2022 semester. Test case 1. So in this test case, there are 4 compulsory courses students had already taken. And these are the only courses the students was eligible to take. Not all these. So only those courses will come for the specific student. And then student can view the distribution and separation and choose courses according to these values, which is like 1 and 2, 1 and 2, 1 and 2. So the higher level values, the student did not choose 380 because it has a 0-0 classification. Similarly, the red ones are the labs, so they can choose the labs as well. So here, I'm sure the labs are not chosen for this specific semester. Another example is here, and in which again you can see this student had taken 10 compulsory courses. So the higher level courses are there, and the light blue ones electives also. And again, the darker portion courses the student have selected because they are more appropriate. Here, definitely 0-0s are there because most of the courses are with 0-0 levels of hierarchy. Okay, here it is. A smart course planning system is devised to facilitate students fulfill their requirements in a structured way and without encountering any unnecessary delays. The system is devised to guide students in selecting from 4 to 7 appropriate courses for the next semester that's suitable for online registration. So this is done a little bit quite ahead ago, and then when they go for registration, they can see the whole structure in front of them. Okay, thank you very much. So let me because right. Yes, Dr. Patil.
Participant, any question or query? Yes, Dr. Paliwal.
Yeah, I don't have any query regarding this because he has summarized with the test cases. Just wanted to know, like, what is your major feature with the existing course planning platform, other than existing systems?
We have a banner system in our thing, and we have degree work. Okay, so these are, these are well established systems from there, but the problem is in the degree works, again, they need the help of an advisor. Okay, so the issue here is, as I said before, I'm an experienced faculty member here, but there are new faculty members, and then typically what happens, students end up, the typical scenario I'm going to tell you, end up not selecting courses for some specific semesters, and in the end they find out they cannot graduate because their semesters are missing. So this gives them a little bit more help in seeing or foreseeing the things, what things can happen, so they can plan a little bit earlier.
Okay. Thank you.
Thank you so much.
Participant, any question? Still we have 3 minutes.
Let me, I'm sure if the audience are there, we have a very sophisticated, our PhD and master's program, and our university also pays the PhD and master's students. So if you people, if the students of your different institutions can, and we have many, students coming from India. So my suggestion is we have our PhD program is there. So I think if you can go to our website, you can find a lot of opportunities for your students. We pay health insurance as well. We pay accommodation as well as 5,000 dirhams a month for 4 years of PhD program. Okay.
Thank you, Dr. Lagari.
Yes. You're welcome.
Dr. Paliwal?
Yeah, yes, sir.
So would you like to conclude the session?
Yeah, I would like to. Thank you, KK Patel sir, for the opportunity he has granted to me. It was a nice session, and I can see the very diversified field research has been carried out by the researcher. I wish him all the best for your future endeavors, and hope to see you next time again. Thank you so much.
Thank you very much, Dr. Paliwal.
Hello,
Yes.
sir. Sir, I want screenshot while I was presenting. I actually missed to take a screenshot. So is it possible? Can I take it, or can you provide it to me?
We'll provide you, no problem. Or else you can download the video that is available in the Microsoft Team. From that you can get.
Okay, sir. Thank you.
Okay. Sir, may I leave?
Yes, Dr. Paliwal.
Okay, sir. Thank you so much. Sir. Thank you.
Dr. Karas? Are you there?
Yes.
Okay. So you can start your presentation and you can share your screen.
Okay.
Yes, your screen is visible.
It's visible now. Okay, perfect. So let's go.
Just switch to the presentation mode.
Okay, thank you for this invitation. My talk will
Let me.
be about.
Okay, no problem. You may continue.
Yeah, my talk will be about big data and AI-driven approaches for sustainability development goals. My name is Dimitrios Karas. I'm professor in computer science and artificial intelligence from Greece, National Kapodistran University of Athens, and also I am head of software engineering department in Canadian Institute of Technology in Tirana. What is this talk about? It's about a major issue emerging since 2010 or 2015 best, which is sustainability in development. Of course, the initialization of this consideration starts earlier during 2000 from United Nations and many other organizations which defined what is sustainability development goals. It encompasses all sectors of economy, all sectors of society. This is the plan. The plan is to monitor because we have now the technological possibility of all data, and data are big data now, coming from human activities, digital activities, and any other kind of activity, in order to monitor processes and the footprints, the impacts of companies and countries in the world. If we are talking about the data that can be used are coming from social media profiles and exchange of information, social media, news and reviews, web searches in Google, for instance. Every month or year, Google sends statistics about the searches. So these are coming from individuals all over the world. We are talking about really big data, and as you understand here, in this first, let's say, sector of data, NLP, natural language processing, is heavily used. Business processes, we have transaction data, banking transaction, companies transactions, we have therefore corporate data, and we have also government data. And the last and very important is about sensor networking all over the world. Some samples, not only. It's about coming from satellites, satellite images, also hyperspectral imaging that makes possible even monitoring of the seas and coastal monitoring and ocean monitoring, geolocation, and many, many different sensors all over the lands in the world. Of course, here we include even the traffic cameras, even the cameras spread all over a country and cities, major cities. So this data is also connected to safety, one of the sustainability goals. We understand that we have different types of data and all have some characteristics. For instance, data velocity, if we consider in real time or in periodic instances, periodic batches of data, we have volatility because we have a lot of the monitoring of changes in environments, business processes, standardizations, technologies, and so on. We have the variety of data, I spoke about this, and of course, we have from small data, some megabytes, up to petabytes data volume. Therefore, we should have into our mind that various kinds of data are collected and how they are processed through data science, of course. As you already know, the major activity here is to start from raw data and through data cleaning and data processing technologies, data pre-processing, we go in this data processing, not to forget, we need even machine learning and artificial intelligence, but for all major activities in order to process this data, we have to understand regression, either logistic regression or not, classification tasks, clustering tasks, factor analysis, for instance, independent component analysis, which is more machine learning, or principal component analysis, etc. We have time series forecasting through deep learning or not, and we have also reinforcement learning. These are the major, up to now, technologies of machine and deep learning and artificial intelligence. However, as you understand here, the majority of techniques come from machine and deep learning, not for classical AI, which is for small data only, unfortunately. So these are the important technologies in all this big data analysis. You can see the data inputs needed. They come from all these data systems, sensor systems, new social media, geodata, satellite data, NGO reports, corporate reports, websites, government sites, and so on. We have the data preparation tasks. First of all, as I told, tokenization is used in natural language processing, as you already know. Word lemmatization is, after tokenization, is to associate with dictionaries. Or we may have speech tagging even. The data are not only data, but data, let's say, written, or but also spoken data. And from this on, we go to modeling. And modeling, these techniques are in major used in natural language processing. So this research is not shown here very well because it's not natural. All these are natural language processing models, but we have imaging, we have signals. We mean here that it's not only this, but many other levels inside level 2 of modeling. So imagine the thousands, millions, billions, and trillions of data, of different type of data, from signals, images, to natural language processing, because this is the real variety, up to figures, numbers coming from time series from companies, either governmental or corporate. And of course, the output for this natural language processing block diagram, as it is now, not for signals and images, we have sentiment, for instance, analysis. We may produce the sentiment indices. We can use word counts. The issue here is to classify sentiments, where and how, in tweets, for instance, critics, comments, these are coming from tweets. And sentiment analysis is one of the major analyses. My research is more in hospital-based comments. In FAST, we have the so-called SDG, which is the Sustainability Development Goals, and ESG. And we go actually from ESG to DSG. What is ESG? Environmental, social, and governmental data and standards. You may ask, are there standards for all this? We try. In our view, we are behind our goals towards real SDG analysis. So you can see here in fast again, because my time is limited, what happens, what are the real sectors of SDGs, starting from poverty, for instance, to human rights, to health, to education, to safety, to protection of the planet, and so on and so on. So for all this, they are, as you can see, 18. We have 18 sustainability development goals. What is the issue here is to have indicators, specific indicators, for all these different sectors, and starting again from United Nations up to now, 2022, there are task forces and all over the internet, let's say, and through organizations, in order to prepare such indicators, such indices. And we see here in this diagram, based on these indicators and the sustainability development goals in the other coordinates here, and you can see in all companies, in all organizations, what happens with the mentions of indicators. So here, for instance, in the first, this figure, the revenue of companies, of corporate companies, of course, uses these indicators even in 75%. But you see, the rest of indicators are not really used in this sample of companies. This comes from large, let's say, reports for 100,000 companies all over the world, coming from JP Morgan. The compliance also is small. We are in the beginning. You can see what we want is to visualize data in more complex ways in order to take into account the footprint and real world impact. You can see from 2D to 3D what happens with the impact. And an important thing here, in such a complex system of monitoring the world, as you understand, we have an entity network mapping for each company and for each organization. You can see here the relations of the company to the other sectors, including government, environment, society, subsidiaries, and so on. So I will go to here to see that at least in sample analysis, the sustainability development goals approached through theoretical such indicators and portfolio scores from the company. This is companies, an average in companies, are close together in definitions. And here you can see our graph about what happens in the analysis of earnings in companies if they follow or not follow SDG. Here you can see that the earning yield, if you follow SDG, is higher. It's a bit higher. Following SDG goals, which might mean in our minds having costs. If you see the graph, we see that if we follow such goals in the long term, we have better even earnings for corporate companies. You can see some analysis you have done based, of course, on limited data, unfortunately, coming from major organizations to see what happens with indicators of SDG and real data. And we see how these are followed in different regions. Correlation analysis, okay, we'll skip some things. And of course, what is very important is the progress through time series analysis. We involve here deep learning for LSTM actually for prediction in several countries and areas, including Switzerland, Singapore, and Germany. And you can see how is the SDG goals. You see hunger, for instance, now is in a better situation all over the world. Stability here is for also for gender, also for economy. You see stability, no something special regarding these indicators. And also we may have even, and this is very important, how these SDG goals, the 18 SDG goals, are interconnecting. How are interconnected? They can be interconnected through Bayesian network, entity modeling, and we can see in such graphs that we can see the correlation or the relation between the different sustainability goals, for instance, hunger, peace, and so on. Such graphs to produce from data, real world data, are important in order to see interpretation and monitoring of world processes. So, concluding, I can say that we have a long way. The techniques now are easily applied. All this work is based on Python libraries, very easily applied everything. The data exists as raw data. All social networks can provide. We lack benchmark data. We should be much more organized. I personally believe we are in the beginning only of such a work for monitoring. And what you see here is actually from sentiment analysis and NLP, and not only financial indicators. These are concrete. The rest, the alternative data, are not concrete. Whatever has to do with figures of development, we know for sure they are concrete data. But the alternative data, this is my talk about, the alternative data, they are a wealth of knowledge, potential knowledge, and not many things have been done up to now. Thank you very much for your attention. I hope I have been within the time limits. I hope.
Yes, sir. Yes, Dr. Karas. Participant, if you have any query or questions. No question from the participant? Okay, Dr. Karas, thank you very much for sparing your valuable time and giving this talk on this very important topic, that is SDG, Sustainable Development Goals. And it's like a really it's useful to us about this SDG. Thank you very much, Dr. Karas.
Thank you very much for this invitation.
Yes, thank you. The next speaker is Dr. Krishnan Kumar, but because of unavoidable circumstances, he is not able to give his speech. So we'll take a break and we'll back at 1:15. 3:15, sorry.